Yeah, thank you very much, and thank you for the invitation. I'm quite happy to be here and to show some pictures about ice architecture, especially in Barcelona, because we made a connection with Barcelona in this funicular ice show. So I will show you later. If you think about funicular ice architecture, then I have some. This is then I have so then I'm thinking about this. So this is the ice castle of Disney from the Frozen, and the other is just an animation of the cicada familia with a lot of ice. So that's a bit my reference and my dream. So we try to do something like that. First, I will show you some pictures of things I did in the past and how I use them at the end to make ice structures. So quite some years ago, about 10 years ago, we did a project with an artist, Jurgen B. We tried to combine synclastic and anticlastic surfaces with membranes as a mold for making composite structures. So here you see the combination of inflatables and pre-stressed membranes, and how you can combine them to make, and in this way you have a kind of clay to make all kind of shapes. Here you see us practicing this. Everything which I did was always done with a team of people. So in this case, Rogier was involved. Rogier Hartman from Tentech. And we used this inflatable to make this composite structure. And here you see let's see. Yeah. Okay. So we made this strange piece of art. Design was by Jurgen B., who is a quite known designer in Holland. So actually, all my research is about molding techniques, flexible molding in different materials. So in this case, composites. And part of that research was also to see how to use membranes to make curved structures in concrete. So one of the cases was how to rebuild the Philips Pavilion. The Philips Pavilion is a pavilion for the World Exhibition in Brussels in 1958, and they made it with prefabricated elements of 5 centimeters thickness on a wooden scaffolding, and like you see on in the right picture, and the pieces were made as a kind of puzzle on a sand mold, and they were moved. And here you see the scaffolding needed to make this pavilion, just for one exhibition, being there for a couple of months. So there was an initiative in Eindhoven to rebuild this pavilion. Design was by Cimne and Le Corbusier. And we thought, okay, let's look at shotcrete and what you can do with this, and if you can combine shotcrete with membranes. So we did some testing. Here you see the inflatables. The inflatables also used for this composite pavilion I showed you before. So we are reusing molds quite a lot. That's the benefit of inflatables. You can reuse them for, like you see, for composites, but also for other materials. And I will show them later. I also use them for ice. You can spray concrete in all kind of directions, even on the ceiling, and even on a membrane, like you see in the left picture. We made an arch on the left lower picture on the membrane. And so we thought, okay, this is the model of the Philips Pavilion. Let's see if we can make one part of it. We scaled it a little bit down because the pavilion was 22 meters high, which is quite a height. So we made one part, like you see here, and we had one membrane here, tensioned. On one side we put some insulation, like you see here, and then we sprayed concrete on it. And in this way we made a shell structure. We took this part open to show how it was done. And in this way you can make quite nice shell structures. And here we showed in how you can treat the surface in different ways, so you can make it as smooth as you want to. Depends on the plasterer you have and your own opinion about how it should look like. We also made a small one, like you see here, with a net structure, so not with a membrane, but with a net structure becoming part of the shell structure. And the benefit of net structures is that they can quite easily adapt shapes, so you do not have the problem of cutting patterns. With the same method, we realized I was involved in this project designed by Maximiliano Fuchsas. This is in the center of Eindhoven. Eindhoven is kind of Philips town, so Philips had his factory there. So at first we made proposals to do this with an inflatable. At the end it was done on a wooden mold, but the spraying of concrete and the method of plastering it and the surface treatment was done in the same way as we should have done with an inflatable. So here you see the spraying of the concrete. To have a better control of the thickness, we did it in parts, like you see here and here. So we did it in parts, and then in the parts in between we sprayed later on. So in this way we could be very in control of the thickness. You see quite a lot of reinforcement. That's because it is in the center of Eindhoven city. And so if there is a soccer game or things like that, people should be able to dance on it. So that's why there's maybe a little bit too much reinforcement. So here's some pictures. So now I come to ice. So we studied all kind of, or I did. I'm aware, of course, of the work of Heinz Isler. Here's a picture of what he's done in the past with inflatables. And so you can have an inflatable sprayed with water, making a kind of dome structure. Remove the inflatable and you have a small igloo. But this is done by more people. And also by Matti Orpana. He made inflatable of about 50 meter height. So this is 50 meter here. You see a car on 50 meter span, which is up in the north of Finland. And I've visited there, and I've been there and was in contact with Matti. So he showed how this was done. It was done also with snow and ice. So here you see a pump inflating the inflatable, and this is ice. So this is a thickness of about half a meter of ice. And here you see the tube with water. They're still spraying it. You can also do this with snow. Snow has some other properties, so it creeps quite a lot. So the wall is much thicker. It's a thickness of about 3 meters. And here you see the inflatable popping through the snow, and you still push spray as much snow as you can until you have enough thickness. And that's done in this way. Then you can go inside, and inside it's about 0 Celsius. If you're outside at minus 20 or whatever, then it's quite convenient. So it feels like being a regular house. but so you get more or less, yeah, usual to to these low temperatures. What I like in this picture quite a lot is that you can see the layers of snow. And I was here in April, and when they started to make it, the height of this door was about 2 meters. And when I was there, it was about 160. So it really shrinks. So it's actually it's adaptive for living structure. So some ice blocks. Most of the structures done in ice are always in blocks. So it's a quite heavy structure. So they're not funicular at all. They're quite heavy. But the good thing is that their translucency, of course, which is nice. I was asked to make an ice dome in Amsterdam in September. So too warm, no ice at all. So how to do this? So I had contact with a company for cooling devices, and I had already this inflatable. We covered it with tubes, connected it to a cooling device, and in this way we made a little layer of ice. And after the success of the small experiment, we did it a little bigger. My lesson is always that try to do your experiments as small as possible, scale it up a little bit more, and then after that you do the full scale. So you can learn by doing experiments. So it was, the inflatable was covered with tubes, connected with a cooling device. Here you see it sprayed with little muzzles. Here the air pump. And this was inside. The air temperature was about 20 Celsius, but because of the very direct cooling, you can do this. And so we had some students helping us, spraying it, removing the inflatable. Here you see the inflatable spraying from the inside. And this was the final result. And actually you can do this everywhere. So my dream is to do it in Kuwait somewhere, or at Abu Dhabi in a shopping center, because they have to cool it anyway, and it's just a little bit deeper cooling. They have enough energy, so that's no problem. Then I came in contact with the material Pykrete. Pykrete is named to Mr. Pike. Mr. Pike was he was in a marine officer in the British Navy, and he was quite involved in developing all kind of the technical developments. He was a kind of innovator, and he was aware of that you could use sawdust to reinforce ice. And the good thing, if you put sawdust in ice, is that it becomes stronger. So it becomes 3 times stronger. But that's not the only thing. It also becomes ductile. So it's 10 times more ductile than usual ice. So ice, if you throw it on the ground, it's brittle. It will break in parts. If you have Pykrete, you can smash it on the ground as hard as you want. It won't break. So it can have quite a lot of impact. So Mr. Pike, here you have him. He came with ideas like this to have very big, reinforced ice ships floating around, fighting the Germans, and that was his idea. He was in good contact with Churchill, and they did all kind of experiments. At the end, it didn't work. Now, for obvious reasons, of course. But the idea was interesting. Actually, they used Pykrete to reinforce the ice on the lakes around St. Petersburg, in the battle around St. Petersburg, so that the airplanes could safely land on the lakes. So that's the only usual or good application I found of Pykrete. The other applications are also interesting, but only fun related. So here are other research of reinforced ice. So this is reinforced ice. So you see it becomes brown because of the fibers, and this is also casted. So this was done in Alaska. So we did some experiments ourselves. So this is an inflatable, and we in the winter in the east of Holland, we mix snow and water and made this kind of arch to see if it works and how it works. So this was the very beginning. Then we did quite some testing and in a freezing cell, looking for all kind of the material properties, the size of the particles, how much you should have within the ice, because there's quite a lot of research, but it's not always the same with the same results. So we did our own material research. And the funny thing is what we found is that the smaller the particles, so very fine sawdust, has a better result than longer. So it's more about the connection between the fiber and the ice than the length of the fiber. So we did quite a lot of testing, and we're still doing quite a lot of testing. Also in pumping devices, seeing how to spray it. So we looked, we had this experience with shotcrete, and to see if you, because everything we found was always casted, and we wanted to spray it, and to see how to spray this fiber reinforced ice. So here you see all kind of molds, testing devices. So we took some snow from an indoor ski slope. We mixed this with different sizes of particles. Okay, so we looked at the snow ratio. Here you see the samples. And here the results. So this is the regular ice in flexural strength and compressive strength, and here you see that it's almost 3 times or even more stronger. Okay. The melting is a little bit different from regular ice because of the fiber. So at first it will melt a little bit faster, but later on the fiber will insulate the ice in the middle. So then the melting down is even slower. So that's okay. So we thought, okay, if we have a stronger material and if you can make domes, then we should see if we can make a larger one. So we looked for domes. So what was the largest dome we could find? We were surprised to find a dome with a span of 25 meters. And because we thought, okay, because of this material, we should do better, then we thought, okay, let's go for 30 meters. So here you see the historical development. So we have ice castles since 1888. Mr. Pykrete, the developments by Matti Orpana. And then we bumped into Kokoa, who made a 25 meter span ice dome with an inflatable on ice. So we had to find a place where to do it. So we found someone in Jukka, and he said, okay, come over to Finland and you can do it over here. So it's not in the deep north, but it's quite close to the Russian border, and from the cold from the Russian, we should be able to do this. So we looked into the shotcrete, looked into all kind of pumping capacities and how to do this. At the end, we found the most simple pump, and you could spray it. This is just around Eindhoven, and here you see a mixture of water and fibers being sprayed. And here you see how we have this sawdust in Finland. This is already in Finland. Here the mixture of water and sawdust, and here the spraying on the balloon. So for the balloon we looked to the Cocoa method. He already made this 25-meter dome, and we researched all kind of methods, and we came to the conclusion that Cocoa did a very good job in this. So he was really, it was a very simple method. The form finding is done by a cable net, which is just pushed upwards with a spherical balloon. And in the balloon there's almost no form finding, so it's just pushing up the cable net like a blader. So here you see how Cocoa is doing this, and actually he's working with a ring here, and that's the only thing we changed, because making a ring takes quite a lot of time, especially when you have very dense ice. So it will take you about a week, and because we are from Holland, and coming to Finland is quite an effort, and we do not have 1 week extra. So we changed this. Here you see the result, how Cocoa is doing this. So we changed this foundation ring, and we made a lower dome. Doesn't matter for the size. So we did some experiments just with inflatables like you see here. A little larger inflatable, and we sprayed it also at the endorsed key slope just to make a little dome to see if it works or not. The calculations of the shell, actually when you have the top of a parabola, it's almost it's almost a circular, like you see here. And if you only have this top, then you will only have compression, almost no tension. So we did some analysis in so the maximum tension we have been calculating with was 1 Newton. Here you see the construction of the inflatable. This is the inflatable we made. Just 2 fabrics welded on each other. And here you see the construction on site. So the net structure below the inflatable, and here you see the inflatable inflated. We used just a PE foil, very thin foil, so all the forces are taken by the ropes, and the PE is just very elastic material. Actually, the pictures of the inside of the inflatable are the nicest, I think. But here you see a spraying, and we sprayed this Pykrete only in this ring, so not on top of it. Later that gave some problems, because if you spray water in a very cold temperature, you will have some cracking, some thermal cracks and shells. So, and okay, we succeeded by spraying quite a lot and having the temperature, try to have the temperature on the same level. But if you wait quite a lot, if you wait a while and the temperature goes down and then you spray, then it will really crack harsh. So we also had to work 24 hours. So we had 4 shifts continuously working to keep up everything running and also to be in control. In Finland, you do not really feel the difference between day and night because there's not so much light. So yeah, it's a little bit strange what is happening with yourself. So the time is a bit strange. So it's becoming kind of so we even had some help of the fire resistance for the last part, and here you see the inside. So this is the translucent part. We tested this with some sandbags, and then we had an opening party. Afterwards, we took out some samples to have a look what we have done and how good we have done it. And here you can see it's not everywhere homogeneous, or almost nowhere homogeneous. So we did this testing. So from the laboratory we had this kind of results. In real, the ice was even better, plain ice, but the Pykrete was much lower. So in laboratory it was 12, but in real we had about 5. Here you see me showing Pykrete. Now what goes up must go down, so this was the beginning of the melting down. So what to do after that? We started with Heinz Isler with his inflatable, but Heinz Isler did also sheets like these and net structures. We also did some testing in Finland with net structures in ice and sheets. So we thought, okay, let's see if we can make this Cicada familia in ice. So we went to Barcelona, studied the Cicada familia, and we were a bit overwhelmed by our enthusiasm because it's quite large. We got the drawings from Jordi Fauli. He was quite generous, and he helped us with some material. Actually, the Cicada familia will have a tower of about 170 meters. So we sized down the whole church with 5. And in a regular church, you have these arches at the outside, and the main thing with Gaudi is that he doesn't accept these arches at the outside, so he brings them inside. So here you see a regular church, and this is the Cicada familia, so he brings all the structure inside. So here are the 2 differences. So we made this connection, the experience of the Pykrete dome, Heinz Isler, Gaudi, and we tried to make this Cicada familia in ice. We took the biggest, the most important parts, and we combined them into this design. So the big inflatable with a 30-meter high inflatable, and this is 21 meter, 18 meter, and here are the nave. So a night view, here you see. So this is the way we making inflatables. Try to avoid that they will bump down. Having the foundation in ice and then inflating in them. And after the towers, then we have the nave. So our calculations in Abacus. Actually, here we couldn't use the road net because of this didn't work as with the dome structure. So here we used this method with an inflatable anchored to the ground, and then pushing it upwards. So here you see the moldings, also just two flat pieces of fabric just welded on each other. Here you see students working at Polynet in Steenwijk, welding the structure. Here the nave. Actually, the nave was quite the inflatables was not the biggest problem. The nave was much more difficult. We made models in physical models, digital models in GSA. This was much harder. Actually, we couldn't prove the stability. Here you see the making of the rope nets. And also making the roof structure of the inflatable, here the entrance. Here the inflation of the 30-meter inflatable. We couldn't succeed to do it in once, so we had to do it in twice. So after some struggle, we came to this method where we first froze down the foundation and afterwards we inflated it. And the rope net is there just to stimulate the ice structure, the making of the ice structure on the smooth surface. It's not for structural reasons. Here you have the big dome, same way, first having the foundation, and then complete inflation. We have a snow machine here. And here you see the layers of Pykrete and snow. This is at the entrance, so it is less homogeneous. But in the tower itself, it was much more homogeneous. Here the ice pins. On the rope structure, you can see here the rope structure and there, which was a kind of gift. I liked it quite a lot, and it's also a good reference to Gaudi. Here the nave structure. At the end, we made this one. It's not what we designed, but I liked it quite a lot. Yeah, I know. I will click through, like you see here. And this was the final result. So for next year, we will do some more research in ice, in reinforcement of ice. We will look into cellulose because cellulose is easier to handle, and we will also look into the combination of fabric and ice, ropes and ice, to look at. So you see, when you have two layers of fabric in combination with ice, you will have a much more better behavior, even avoiding cracking. Here you see us testing cellulose, and for this year we will have around arena here, which is a big quarry. We will make different structures. So a pavilion inspired by Candela, an ice bridge inspired by the design of Da Vinci. And in the quarry we will make a kind of frozen waterfall. So it will be a kind of ice paradise. So here after Gaudi we looked for Da Vinci. Here the design by Da Vinci for the ice bridge. Here are some animations of the bridge. And here a very big inflatable. We are now researching and engineering. Here the sections of the inflatable. And here how we want to do it. So first the inflatable, spray it with ice, remove the inflatable. And then we should have a span of about 50 meters. Here are the models we made. Right now we have quite a lot of schools involved, and from Bath and even from Portugal, and quite a lot, of course, in Finland and around Holland. Of course, we also have quite a lot of support by companies. We cannot do this alone. We also raised the association to be in control of the financials and so on. So this is Jukka, where we are doing this. It's not always cold enough, so it's sometimes you also have some time for fun, like you see here. Okay. This year we will have an ice symposium at the opening. So the opening will be in February. So you're all invited to be there, and so there will be some flyers at the end. Thank you very much for your attention.